Let's go to equals 3290. Maximal multiplication score for this question to give us an integer uh, a and an integer b. And you see that a has size 4 and b has size at least 4. We want to choose 4 indexes from the b, and so that I0 smaller than I1, smaller than I2, and smaller than I3. You want to maximize the score A0 multiplied by BI0 plus this kind of until A3 multiplied by BI3. Want to find the maximal score. Let's look at the example, right? So if we select 3 multiplied by 2 and 2 multiplied by -6, and select 5 multiplied by 4 and select 6 multiplied by 2. The result is 26. That is our maximal score. So this one, you say that A, we need to select all of the items, right? But we can consider more generic cases. That is, we have two arrays, A array and a B array, right? And A has size M, B has size N. From A, we want to select P items for calculations, and from B, we want to select Q items for calculation. We want to find the maximum summation of the calculations, right? In this case, it is quite a generic dynamic programming. So for example, we have dpij, right? That means from m items, we select items. From n items, we want to we select j items, the maximum score. So we have 3 choices. That is, if we don't use I for calculations, then here we don't use it, right? So we know dpij will be dpi -1 j, right? And then also we have a choice that we don't use j for calculations. That is dpi j -1, right? Another is that we use dpij for calculations. That is dpi -1 j -1 multiplied by a, because that is with select I item, right? So we have index possibly -1, b -1, right? So we find the maximal for these 3. For this question, every eighth item we need to select. That means this kind of scenario is not the case, right? We cannot ignore any ith item, right? So let's say we have we have only just need to max 2 values. So we can write code for this, right? So we know int n equals b dot length. We have long dp equals new long. So let's say it has we'll have one more items, because for 5 means we have 5 states, right? Select 0 item from select 1 item until we select 5 items, 4 items, right? So let's say dpij, right, will represent from B, select the I items, and from A, from select G items, the maximum score. Right? So this is the DP. As we talk about the dpij will be max.max, right? Max of dpi -1 j, right? Actually, this we should not consider this, because A has size 4. Every A item we should select, right? I mean, do not consider this. We don't consider this, right? Because now we put A just on the second dimension. Okay, so we need to consider this, and dpi minus 1 j minus 1 multiplied by 1L multiplied by a b I minus 1 multiplied by a j minus 1, right? So this will be the transition function. So what will be the initial state? Actually, we should write initial state like this for int I equals to 0, I smaller than n plus 1, I plus plus, and we'll say for int j equals 1, j smaller than 5, j plus plus. We're going to have dpij. Because we want to get a maximum value, so we should set this one as the mean value. Let's flash it to 1. There is one special one thing to consider is that we should use I for I equals 0 instead of for I equals 1, right? The reason is that of course, the G0 means we select nothing, then the score is 0. It's unstable. But for I equals 0, why we should also still set a minimal value, right? Because consider this. Just dpij, we can always come in from dpi minus 1g, right? So if we set this one as 0, right? So that means the final result should always greater than equal to 0. But let's consider some kind of scenario. For example, a will be -2, -1, -3, -4, and b to be all positive number, right? So the final result should be a negative number, right? So that means we cannot use non-selection to get 0 scores, right? So for I equals to 0, g from 0 to 5, we should also set as minimal values, right? And then let's write, so this is why we should start I from 0 instead of 1, right? We cannot use a non-selection to make the score as 0. And then what we do is that we just do for int I equals to 1, I smaller than n plus 1, I plus plus. Then we're going to have for int j equals to 1, j smaller than 5, j plus plus. And we'll have dp I j equals max dot max dp I minus 1 j, and then dp I minus 1 t minus 1 plus 1L. Here, that is because this is the int, right? And we should convert to long, right? So b I minus 1 j minus 1. And then in the end, return dp and multiply 4, right? So that will be our result. Here, we'll see the result is the time complexity will be n multiplied by 5. But we'll see every dpij is only dependent from dpi minus 1 j, I minus 1, j minus 1, right? So we know the space, we should be able to save the space. We can use a rolling array to improve the space complexity. So for the rolling array, right, we just need to have int long 2 multiplied by 5, right? And what we do is that we just need we don't need this for I loop, right? So we know this 0. be this, right? And for every I, which is multiplied by 2. So in the end, we just return this one multiplied to 4, right? So doing like this, the time complexity is still O n multiplied by 5, but the space it will be constant. And okay. Actually, let's look at the original code, right? Original code is like this. So we'll see original code is like this. We know we can use a rolling array to improve the spacement. We'll see space complexity. We'll see to change the also the time from 39 seconds to 17 seconds. But let's look at this one, this kind of for loops, right? So we'll see every dpij is coming from dpi minus 1 g and I minus 1 g minus 1, right? We know in the 1 backpack problem, we have a similar for loop. That is every dpij is coming from the top item and the left top item, right? So we can use one-dimensional dp to simplify to improve that space complexity, right? So instead of writing rolling hash, we have another improvement is using one-dimension array, right? So use one-dimension array, and here, here there are 2 dimensions. One is n dimensions, right? That is the base items. Another is the 5, that is eighth item. So which dimension should we keep, right? So if we still keep the n, right, it's meaningless, right? But the thing is that we can delete the this kind of dimension to be long 5 only, right? So what we do is that we still need do like this, right? So the for int j equals to 1 is smaller than 5, a plus plus, let's say dpj equals in long dot mean value, right? Shift 1, right? And we don't need I. So that means that we'll see every dpij is coming from here and here, right? So remember for one 0, 1 backpack problem, that is for the inner loop, we should do reverse iterations, because when we calculate this part, we make sure we are still using the previous line's code, right? Otherwise, if we use a forward direction, then this value already been updated to this, right? So that will be wrong. So in that case, we should have for j equals 4, j greater than 0, right? J minus minus. We are going to have dpj equals max dot max dp j, and dp j minus 1 plus 1L multiplied by a j minus 1 multiplied by b I minus 1. And in the end, we just return dp4. So you'll see, because we don't use mod, it is much faster than the rolling array, right? Even the space complexity is still constant, and we didn't the time complexity and the space complexity it still keep the same as we use the rolling array, right? Let's convert this to Python code. So we'll have dp equals float minus 9f multiplied by 5. And we'll have dp0 should be 0, right? Let's have its length out as well. The length of it. So what we do is that for I in range from 1 to n plus 1, right? So we know the inner loop for j in range from 4 to 0 minus 1, right? Because actually remember that is iterate to 1, right? Greater equal to 1 in Java code. So we'll have dpj, right, equals max dpj and dpj minus 1 plus aj minus 1 multiplied by bi minus 1, right? So in the end, we just return dp4.